This is an extension of the last PowerPoint about predicting molecular polarity. In some ways, I think this sheet will give you more of a clear roadmap for how to do it. But again, it'll be a lot easier once we actually do some examples and show you with molecular models. So basically, this is going through all the steps to determine if a molecule is polar or nonpolar. So overall, does the molecule have what's called a dipole? Dipole just means two poles, and one's going to be slightly positive, slightly negative. Remember, we were teaching you about those small lowercase Greek letters, the Greek deltas. So you have to go through all the original steps. You've got to get the Lewis structure for the substance. Once you've got the Lewis structure, then you go to your A's, X's, and E's to figure out what the name of the shape is. Once you have the name of the shape, then you can sketch it. And then you look at the bonds involved in the molecule. And you're looking to see, typically, since we're talking about molecules, we wouldn't expect to have ionic beasties here. So we want to know, is it nonpolar covalent or polar covalent for each of the bonds? It says if there are no polar bonds, the molecule is nonpolar unless there are lone pairs of electrons on the central atom. So that means it's not a parent shape. If the molecule has polar bonds, then you have to go to step 3. If there's only one central atom, you want to look at what the electrons are doing around the central atom. So if all the bonds around the central atom are the same and there's no lone pair, that's another way of saying it's a parent shape. The molecule is nonpolar. If there's one or more lone pairs in the central atom, the molecule is polar. And it's going to, dipole points towards the lone pair. And if the central atom has at least one polar bond and the groups of bonded to the central atom are not all identical, it's probably polar. And so it says, hey, once you've made that, then you make your sketch of the molecule. And if it's polar, you're going to put in an overall arrow to represent the dipole. And it points to the thing, the part of the molecule that wants to be the most negative, the highest electronegativity. It also talks about the symmetry. So it talks about using these arrows, and I can't remember if physics is term 1 or semester 1 or semester 2, but I suspect it's semester 2. And that's unfortunate because you will use vector diagrams in physics, and that's something we can talk about at another time. But what you're looking at there is you're going to have all these arrows representing different dipoles for each bond, and then you're going to see if the arrows, their direction and their magnitude allows them to cancel out. So that part we'll leave till we actually have some pictures of molecules or physically show you some molecules in a video where it's a lot easier to do this, and maybe they'll do it in class or it maybe have to be done in a video. How's that for confusing? Apologies.